instructions are, so after every slide I will only ask you if you are having any doubts. No, please raise your hands so that there will be no disturbance with anyone. Okay, right? So if anybody having doubts, no, please raise your hands. We can ask you so that you can raise your doubts and we can clear your doubts. Okay, so in that one, as per the schedule which I had given, so in that one, first we are going to discuss about the, okay, the topic of structure of atom we are going to discuss. Structure of atom we are going to discuss. So when we are discussing structure of atom, no, generally in any atom or generally we are having any atom, we know as per Dalton's theory, atom is the smallest particle which is indivisible. Okay, so this is according to Dalton's theory, right? So what we can say, according to Dalton's theory, atom is the smallest particle which is indivisible. Okay, so, so this is the first point we need to do. But after on, later on, okay, so it was said that by the experiments, it was said that atom also divisible. Okay, so from the experiments, it was said that atom also divisible. Okay, into small particles. That was the from the experiments. It was concluded, right? Mm. From there, what we came to know is in any atom generally there are more than 100 types of fundamental particles will be there. In that one, from the experiments, from the experiments, it was it was confirmed that in any atom, electron, proton, neutron are the basic fundamental particles. Okay, so we are having electron, proton, neutron are the basic fundamental particles. These electron, proton, neutrons are discovered in okay, the electron, proton, neutron were discovered in different experiments. It was discovered. Okay, so in that one, we are going to focus on their electron, proton, neutron. What is the mass number? Okay, what is the atomic number? That only we are going to discuss. Okay, who proposed this and what we are going to find out. Okay, that means simply we can say in any atom, no. So electron, proton, neutrons are basically it is going to be common common particles of the any atom it will be there. Okay. Now, so from this one, who proposed what we are going to discuss right now? Generally, we are having different experiments. We have discovered electron, proton, neutron. Okay, the discovery is not having that much of a wide importance in our examinations, so that I'm not going to discuss that. So simply we are going to discuss whatever the requirement is there. Okay. Mm. And one more point you need to know, um, for any particle, for any particle charge to mass ratio only is known as is known as specific charge. Okay. So for example, as we have from the experiments, we have calculated for each and every atom, no, for every electron, proton, neutron, we are able to calculate charge value and mass of the particle also we are able to calculate. From that one, we can say that specific charge is equal to charge of a particle. Simply we are going to represent with E upon mass of the particle, that is M. So E by M only known as a charge. So now what I am going to give you is simply, let me take particle. What is the particle?
Sir, could you go to the previous slide?
Yes, sir.
Sir?
Tell me.
Sir, I'm Ranveer, sir.
Tell me, Ranveer.
Sir, that means we are already in the structure of atom, no, sir.
I told you it is combined class. For that purpose, I had shared already the topics which I am going to discuss in coming topics.
Sir?
Sir, I have a doubt.
Sir, that means we should write again, sir, notes.
It's up to you.
Okay, sir.
Sir,
Sir,
I have
is
a
there is a difference between this notes and this notes?
Nothing, no difference.
Okay,
Same
sir.
only.
Sir, I have a doubt. So
Tell me.
specific charge means it's the ratio of charge and mass, sir.
Yes,
Okay.
that only I had written, I believe.
So what is the difference between specific charge and charge, sir?
Now, charge of a particle is okay, different, and specific charge means it is the ratio of the particle, okay, to charge to mass
Okay,
ratio.
sir.
Okay, when I'm giving the valuation, you will get that one. Please.
Sir, 1 minute, sir. Sir? Sir, that means after Dalton's atomic theory, they told, sir, that Dalton's atomic theory was wrong.
That only, no, my dear.
Okay, sir.
Okay. Next one, particle. See this. So let me write the particle and relative charge. Next, charge in coulombs. General coulombs will represent with capital C. And next one, mass of particle in kg. Okay. And let me write scientist who discovered also. Let me write in that one. Let me include in this discoverer. Okay. First particle is what? Electron. Electron relative charge is electron will have -1 charge, and actual charge in coulombs is -1.6 into 10 to the power of -19 coulombs, and mass will be 9.11 into 10 to the power of -31 kg. And the discovered by electron discovered is J.J. Thomson. Next one is proton. Proton relative charge is +1, and charge of the proton will be 1.6 into, same it will be there, only sign only changes, -19. Nearly it is same, just only last which are going to be changed. And mass will be mass of proton, no? Mass of proton you can write as 1.67. Mass of proton and neutron same, no? 1.67 into 10 to the power of -27 kg. And proton was discovered by Goldstein. Electron, proton, and next one is neutron. Relative charge of neutron is 0, and normal charge in coulombs also 0 charge it will be there, and mass also similar it will be there, -27. And neutron was discovered by Chadwick. Okay. Now, if I'm trying to calculate the charge by mass ratio, that is specific charge value, E by M value for neutron will be what? Neutron charge is what? Charge by mass, no? Neutron charge is 0, and mass of neutron is how much? 1.67 into 10 to the power of -27. So that value will be 0. And E by M value of proton is 1.6 into 10 to the power of -19 coulombs upon 1.67 into 10 to the power of -27 kg. Okay, that value we can simplify this. We can divide and we can simplify this value. Okay, similarly, E by M of electron also we can define. Generally, protons to charge ratio it will be nearly 9 point something we will get. Next one, E by M value of proton and electron. Charge of electron, that is 1.6 into 10 to the power of -19 coulombs by Mass of the electron is 9.11 into 10 to the power minus 31 kg. Coulombs. Okay, from this one we can calculate the charge values.
Sir, I have a doubt.
Anybody having doubt?
Sir, does
Tell
relative
me.
charge mean the total charge, sir?
Generally, simply what we can say, generally we can say, no, relatively electron is positively charged molecule, neutron is charge, zero charge, electron is -1 charge, simply we will consider, no, that we are saying that relative charge.
Okay.
Okay, whereas charge means exact charge is 1.602 something it will write, actually.
Sir, what is the SI unit of specific charge? Sir?
It is ratio, no, coulomb per made kg it will be there, Nana. Charge is coulomb and that is in kg, no, coulomb per kg we can write.
So what is the E by M value for proton, sir?
Proton is what, 1.6 into 10 to the power of minus 19 by 1.67 into 10 to the power of minus 27, no?
So it's
So
equal
if
to
you
how
want to
much, sir? Equals to how much?
acha, that value you are asking.
Yes,
One
sir.
second. 1.6 upon
Sir, 9.6 into 10 to the power 7. Sir.
9 points, around 9.6 into 10 to the power of
7. Sir.
7. Okay. And coming into neutron will be, sorry,
Sir,
neutron 0, electron will be
1.76 into 10 to the power 11.
6 into 10 power of 11 it will be there. Okay. Simply every unit will be coulomb per kg. So in this one, what is the order of E by M value? Among these three, what is the E by M value, Nana? Which is least?
Neutron, sir.
Neutron.
Therefore, what we can write? E by M value, E by M order is, first we will get neutron. Next,
Electron.
electron. This is 10 power of 11, no?
Proton and electron, sir.
Proton and after that electron. So this is the point you need to remember. Okay. So this is from this one after discovery of electron, proton and neutron. Okay. And these all values are discovered in different experiments we have discovered, right?
Can you show the previous slide? Answer.
So after that, we are going to have models. Okay, atomic models. So before going to go that, okay, before going to that, we need to know about basic definition of what is atomic number, mass number, and how to calculate number of neutrons.
Sir, I have a doubt.
Tell me.
Sir, the specific charge of neutron is 0, no, sir. Then 0 has no value. Then it has to be the less specific charge than proton and electron, no, sir.
That only I have written, no, no, no.
Oh, yes.
Neutron I have written first, no? I had written increasing order, I have written, right?
Oh, yes, sir.
So atomic number means what we can say? Okay, atomic number of
Number
elements
of
generally.
protons.
Number of protons present in the atom.
Generally, number of protons present in the atom or number of electrons of a neutral atom. Okay, generally atomic number we are going to represent with atomic number is represented with Z. Okay, Z. Whereas mass number means what we can, how we can define?
Sir, once can you go to the previous slide?
1 second. Then
Yes, sir.
so mass number means simply what we can say. Mass number means it is sum of protons plus neutrons. Okay, and mass number we represented as letter A. For example, for any element, if I'm taking no X, I'm taking, and we can write X, Z here, and A you can write generally top right or top left also. And here what is X represents?
Elements.
Element, and Z represents atomic number, and A represents mass number. Mass number. And generally number of neutrons of an atom is equal to mass number minus atomic number. That is number of neutrons n equal to mass number A minus Z. That means atomic number A equal mass equal to n plus Z. Okay. Next. The next point is then how we are going to calculate the mass number that all of an element, how we can calculate and how we are going to calculate. Okay.
Sir, can you go previous? Yes, sir.
For example, let me take an element of what we can take. Sorry, bromine atomic mass is 80, right? And the atomic number of bromine is 35. In that one, I want to calculate so number of protons, number of neutrons, and the number of electrons. So it is a neutral molecule. So that number of protons is equal to what we can say,
35.
equal to 35, and number of electrons will also be same. Same 35, and number of neutrons equal to what?
40.
80 minus 35, sir.
Number of neutrons equal to 80 minus 35. That will be 45. Okay. Next one. For example, I'm taking for any atom, if I'm taking calcium plus 2, 20 and 40, if I'm writing. In this one, what we can say, number of protons will be,
18, sir.
22.
number of protons are 20 as it is.
20, sir.
Okay. Whereas number of
22, sir.
Electrons.
number
18, sir.
18.
18.
Electrons 18. 20, sir, 22.
okay, listen. One listen. How number of protons will be 22? Protons will be same, no? Protons is nothing but number of electrons only, no? So positive charge means what? It loses 2 electrons. So number of electrons will be how much generally in neutral atom? 20, and plus 2 means there will be losing 2 electrons. So that it will have 18 electrons. And now number of neutrons is equal to mass number is 40 minus number of protons is 20. That will be 20. Okay.
Sir, excuse me, sir.
Tell me, Nana.
Sir, can you show the previous slide once? Sir, here number of neutrons is n and A is mass number, sir.
Huh.
Okay, sir. Thank you, sir.
Sir, how should we find out the number of electrons?
Number of electrons, generally what we can say, first we need to find out whether it is neutral molecule or not. In neutral molecule, what we are at, an atomic number is nothing but number of protons, right? Number of electrons
Yes,
or number
sir.
of protons are same in case of neutral molecule. If in case of ion, then which ion we need to see, whether it is a cation or anion. Cation means positively charged one, and anion means negatively charged one. So if we are having positive charge, and we need to miss, so positive charge of any element will form by losing of electrons, and a negative charge of any element will form by gaining of electrons. Okay, now coming into this example, I have written calcium plus 2, 20 and 40. That means number of protons under calcium, basically calcium atomic number is 20. That means number of protons will also be 20. Okay, and number of electrons, how we can write? Atomic number, already neutral molecule 20 electrons will be there, and plus 2 means there will be loss of 2 electrons. Okay, so that 18, and number of neutrons will be same. Let me take one more example. I think we can understand very clearly.
Sir, oxygen.
N minus 3, 7 and 14. In this one, say, so minus 3 means what we can say? So nitrogen
Negative.
is
Gaining
gaining
3 electron.
3 electrons. First one, number of electrons will be
10.
In nitrogen, how many atoms will be there generally?
Plus
Seven.
7 electrons are
Plus
there.
one plus
7 plus 3 electrons are gained.
Plus
That
3.
will be 10. And number of protons will be how much?
7.
7. In case of neutral molecule, the number of protons and neutrons are same, no?
Yes, sir.
Yes, sir.
Protons
This
and
is
electrons.
negative molecule.
And number of neutrons are
Newtons is equal 7 is
So
equal to
7,
7.
sir.
14 minus
7,
7, that
sir.
will be 7. Okay, understood?
Yes, sir.
Yes.
So this is the way we are going to calculate number of electrons, protons, and neutrons can be calculated like this. Okay, whereas generally, tell me now.
Sir, atomic weight of calcium is 35.5, no, sir?
Hello, can you
Atomic
repeat?
weight
I'm
of
not getting.
atomic weight of calcium is 35.5, no, sir?
Calcium atomic mass is 40, Nana. Chlorine is 35.5.
Okay, sir.
Now that only I'm going to discuss right now. So the next point of discussion is generally we know atomic mass in these three examples I have written as a simple whole numbers I have written. Okay, but you might gone through certain elements are there whose atomic numbers we have written in the form of in fractions, that is like chlorine 35.5.
In decimals, sir.
In decimals we are going to write, that is 35.5 means what, 355 by 10, right?
Yes,
So
sir.
in decimal places we are going to write. So in such cases how we are going to define general, that we are going to, okay, express in case of average atomic mass we are going to write. That means, so here you people know, do you know about isotopes, isotones, isobars?
Yes, sir.
Yes.
But can I
Sir.
tell? Sir, only
No, sir.
isotope.
One
Sir, can I
second,
tell
one
what is
second, one
isotopes and
second. No
isobars?
one should speak. Okay, I will only speak. Right? Let me write generally. Isotopes means what I will write. Isotopes means what we can say. The species are atom. Okay. The species which have same atomic number but different in mass number.
Sir, you wrote. Sir, you wrote but wrong.
Huh?
Sir, you wrote but wrong, sir.
DUT and ITS. Isotopes that only, no?
Yes, sir.
Example what we can say, 1H1, which is also called as protium.
Sir, carbon, sir. Protium, deuterium, tritium.
The deuterium.
1H2.
Tritium, sir.
Please,
1H2, 1H3.
please quiet.
Uranium.
Those who know, no, please quiet. And 1H3, that is tritium. Okay, this is on set we can write, and we can write it as
Carbon, sir.
carbon 1214 and sorry, carbon 614.
So it's 614. So 15, 616.
6 12 also we can write. Okay, these are the isotopes we can say. Okay, and one more we can take it as of chlorine
Chlorine,
atomic
sir.
number 1735.
1735, 1737.
Chlorine 1737. Otherwise you can write it as uranium 92 235. and uranium 92 to 238. These are also you can write as the isotopes. Okay. In this case of isotopes, okay, in case of isotopes,
Sir,
tell me.
sir, that means what are the names of 6C14, 17
It
C?
doesn't have any names, and simply we will say isotope, carbon isotope with 12, carbon isotope for 14, chlorine isotope 35. We will say like that only.
Okay,
Like
sir.
in case of hydrogen, we don't have any special names for this.
Okay, sir.
Next one. Uh, in case of isotopes,
So they have same chemical properties.
yes. In
So
case of
because the
isotope,
isotopes are same number of atomic number, so due to which the so chemical composition depends upon the electronic configuration of an atom. Due to this, they have similar chemical properties.
yes. In case of isotopes, okay, the atomic mass is atomic mass of the element is average atomic mass. Okay, because of this average atomic mass only, chlorine we are going to have 35.5. Okay, likewise we are going to have in decimals. Generally, average atomic mass formula is average atomic mass formula is mass of first isotope
Mass of first isotope into the
please quite option into its abundance plus mass of second isotope into abundance. If we have third isotope also, third also we will write. Okay,
so you missed one
abundance
thing,
means
sir. It's abundance by 100, right?
abundance by total abundance. Obviously, total abundance will be always 100.
Sir, abundance means percentage, right?
Abundance means percentage availability. Okay, abundance means percentage availability. For example, let me take one question. Uh, Calculate the average atomic mass of neon if uh, neon which can exist as 22 with 10 percentage abundance, neon 22 having 10 percentage abundance, and neon 20 which can have
90%.
90 percentage abundance.
Sir, once can you go to previous slide?
Sir, 20.2.
Sir,
Correct. Mm.
sir, that means it is applicable to all elements.
Which can show isotopes.
Yes, sir. That means isotopic elements. It is possible, sir.
Yes.
Sir, is
Okay.
average mass 202, sir?
20.2. Okay, let me calculate. First, what we can say?
Yes,
Average mass
20.
equal to what? So formula what? Abundance into mass of atomic mass. Okay. Let me write the formula. So average mass is equal to atomic mass into abundance. First isotope into abundance plus
Second
atomic
atomic mass of second isotope into abundance.
second into abundance
Sir,
by
that means by 100
total abundance, that will be 100. That means what is first atomic mass, that is 22
22
10,
into
into
10
10
plus
plus
20
20
into
into
90.
90 whole by 100.
That will be 220.
220 plus
1800, sir.
1800.
whole by 100.
That will be
20.20.
20.2. Okay, mass number we will calculate like this.
Sir, the unit is AMU.
Yes, generally atomic mass units we will write as AMU only.
Okay, sir.
Atomic mass units we can
Sir,
say.
okay. Sir.
So 20.2 AMU.
Yes, 20.2 AMU is correct. Okay. So we will meet you in next class, Nana.
AMU, sir.
Atomic mass unit. AMU means what? Atomic mass unit.
Unit.
Okay, sir.
Bye, sir. Thank you, sir. Good night. Sir.
Thank you, sir. Bye, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Good night, sir. Bye, sir.
Bye, sir. Thank you.
Bye, sir.